So this talk will be not specifically on how to use SQL, but rather what is happening underneath the covers when you're executing SQL queries against the database management system. So it's going to be an overview of how that processing happens against the data set itself, and then two main approaches to how we typically write SQL statements. Those are using joins if you want to get data across a couple of tables, and also another approach is using nested queries instead of using joins. So why is knowing all of this stuff useful when you don't directly use it? Because if you know what's happening underneath the curtains, like behind the curtains, it makes it easier to write some queries that aren't necessarily intuitive. They might sound easy until you sit down and, okay, now I have to actually write it. And if you understand what's happening in the data itself, like how it's getting processed, that makes it a lot easier to write your queries more efficiently. And that's the next point, actually. It's if you understand it, you can optimize for better performance in your SQL queries. All right, so first up is just a basic overview of how a simple select statement gets executed. So in this example here, it's a simple select from some table that has got a bunch of sailors in them, like a bunch of people. And so we want to select the people's names and their email address where they have block spam set to 0. So that's pretty simple, but the order in which this gets executed is first up, the sailor table will get loaded into your RAM, and then the where clause will get applied. So it will iterate through all of the rows, and for each of them where the block spam column is not set to 0, it will remove the row from the result set. And then at the end of that, it will run the select clause, and it will remove all of the columns that you don't want in your result set. Now, this makes sense because if the select ran first, then you wouldn't be able to use columns in the where clause that aren't actually being displayed, which would be annoying. Okay, so then what happens when you run the select? What actually happens like when you use a join? All right, so this is the first processing approach, is using joins to write your SQL statement. So let's imagine we've got these two tables, right? So two very simple tables, each only with one column and some random data in. So if you run a select everything from both of these tables, what will happen is immediately the database management system will go and create a Cartesian product of all of the tables that you specify in the from clause. So for example, it will be these two tables. So what you'll see here is a bunch of these are duplicated. All right. So what happens is it takes the first row here and it joins it to the first, second, and well, to each of the rows in the second column. So that's why you get the A1, 2, and 3. Then it goes on to the next one, next one, next one. So this happens before the where clause gets applied. So first up, this gigantic Cartesian product result set will get generated, and this is all kept in your computer's RAM. And then the filtering happens for the where clause and the select clause. Then also the group by and aggregate functions are also applicable, but they are a bit out of the scope for this presentation. So continuing on the processing approach with join, here's a practical example. All right, so first up, let's imagine that we've got these two tables. So we've got a table with a bunch of sailors in them, and then we've got this table, which is reserves, which would be a bridge entity between the sailors and boats. So the scenario might be that you've got a sail club or something, and you allow members to rent out boats for a day or so on. So this will be the bridge entity, which simply says sailor with ID 22. So this guy, Dustin, was renting out boat with ID 101 on this date. So it's a very simple, this is a very common, like how relational DBs are structured. So if you run a simple select to like a select where, like let's say you want to see which sailors have rented out boat with ID 103. All right, so then you would use this select. So it will say select the sailor's name from the sailors and the reserves table, where this clause, I'll talk about that in a moment, and the boat ID equals 103. All right, so the reason that we need this matching between the sailor ID on the sailors table and the sailor's ID on the reserves table is because this Cartesian product gets generated in the background. So you'll see in this isn't the result set, by the way. This is what's happening in memory while it's still busy processing the result set. So first up, it's going to create the Cartesian product that we just spoke about, and it's going to match all of these columns with every column in the other table. So you see this guy now is like everyone is duplicated in here, and some of this data is actually completely wrong. For example, here it says that Dustin rented out both of the boats when actually he only rented out one of them. He's only once in this table. So that's why we use this matching. So the where clause will then go and say, okay, cool, is this SID from the sailors table the same as the SID from the reserves table? So this 22 and this 22, okay, cool, it's the same. So this record gets kept, and then it will go on over the next record. Where they don't match up, it will get removed, and so on and so on. All right, so this is the same example. It's just continuing on the practical example. And now I want to show you what will happen in memory as this query is getting executed. So first up, it will do this where clause where the sailor ID from the sailors table is equal to the sailor ID from the reserves table. So the first one, it does the check. All right, cool. They're the same. Both are 22. So this column doesn't get deleted. This row, sorry. Then onto the next one, they're different. It's 22 and 58. So what will happen is this row will get removed from the result set. And then the next one, they also don't match. So it's getting removed. 31 and 58 don't match. So they get removed. 58 and 22 also don't match. That gets removed. And then 58 and 58, they do match. So that's perfect. So now the second part is the boat ID should be 103. This one is not 103, so it gets removed from your result set. And now you're left with this result set. All right, so then finally, the select clause gets applied, and it says, okay, I only want column S name for the sailor's name. So then it will run through all of your columns. The first one, that's not specified in the list. So this column will get deleted. The second one, it is actually specified, and then so that one stays. And then for all of the rest, they aren't specified in the select clause. Oh no. So the column will actually get deleted, all of them. So then at the end of this processing, you are left with this result set, which will be what you get back if you actually ran this query against the sample data that we just mentioned. All right, cool. So that's just basically what happens in the background when you execute select queries using a join. All right, so then one thing that you can do that's cool about this, because it's creating the giant Cartesian product, what you can now actually do is you can select data twice from the same table. So for example, you can use select whatever from sailors and then comma and sailors again if you'd want to. So then you can create a Cartesian product with the table itself. So you can compare data in the same tables. Like for example, check out this query. Like if you want to find sailors who have reserved both red and green boats. So what you'll do is you'll join the sailors, the reserves, and the boats table, because the boats table might have the color in a column. So it's specifying the color for you. All right, but now it's difficult because you can, in a single row, only see whether that boat is green or red. So what you'll do is you'll have that matching, the sailor with the reserves and boats, and then you'll have reserves and boats a second time. So you just give them each a second name so that it's easier to refer to them in the where clause. So then we do this same matching that we were talking about earlier here, where you just have to match the IDs between the table and the bridge entity. So we do that for sailor with reserves 1 and boat, which is over here, this first section. And then this which is for the second section, which is between sailors, reserves 2, and boats 2. It's exactly the same. So now you'll get every possible combination of sailors and the boats they rented that were actually rented out. So all of the duplicate data will be removed. So now you can simply say, okay, the boat 1 must have a color of being red, and the boat 2 must have a color of being green. And then you've got your data. So it might not seem intuitive, but if you understand how this Cartesian product is getting populated in the background, it makes it much easier to work with this kind of queries. All right, so then The next processing approach is using nested queries instead of using joins. So I'm not going to talk much about it because it uses the same fundamental approach, but here is just a quick example for people, like if you aren't familiar with nested queries, this is a normal join query, and this is the nested version of the same query. So these will do the same thing. It's just this one is using a join and this one is using a nested query. Now, the main difference here is if you're using a nested query, the from only has one table inside. So it's never creating that giant Cartesian product. And that gets larger and larger as like the more data you've got in your table. So it might become an issue if you don't have much RAM on the system that it's running on. So then you might want to opt for using the nested query instead. But as we expect, this also comes with its own issues. So let's see a simple query. This is one query to just select the names of all the sailors who have rented out a red boat. It's very simple, but this is what the query will look like. Now, the issue here is that it trades in a lot of the memory usage because it doesn't use that giant result set. It trades it in for a ton of processing loops. So it's a bit more CPU time and overhead. So what happens is it's going to be selecting from the sailors table and then linking that up to the reserves table with boats that correspond that have a red color. All right. So now the issue is, for each time, like for each row in this first query, it's only going to run over the sailors table once in totality, like when you execute this query. So the first row for the sailors table, like it's going to start out with this guy with Rusty. All right. So then it's going to need to decide based on the where clause. All right. Should I keep this ID 58 in the result set? Yes or no? Then to decide that, it will first go and calculate the valid sailor IDs that should remain in the result set. But in order to do that, the nested query inside of that one will also need to be executed. So it's first going to go and it's going to execute and run through the boats table, get all of the boat IDs that have a red color for the boat, and then it's going to return that list of boat IDs to the query here in the middle, which is going to be used to filter out which results should remain in the reserves table. And then when this one is finished executing, it's going to return a list of sailor IDs to the first query over here to decide whether or not to remove the row. Now, unfortunately, that happens. The whole process happens for every row. So the next time when it comes to the second guy, to Lubber, is again going to execute the entire this query to run through this table. And for each row in this one, it's going to execute the third nested query in here. So in totality, this one will be iterated one time, the sailors table, and the reserves table will get iterated the number of times as many rows as there are here. So it's going to be 3 times in this case. And then this one will get executed every time this one is executed, the reserves table. So it's going to be run 6 times in totality. So that quickly adds up to a lot of CPU time because it's a bunch of little queries being run and there's a lot of overhead. So it might use less memory, but it might not be more efficient still. So that greatly depends on the data on which you actually run the queries. So that brings me to the final point. What is the advantage of this? Like, why would you use a nested query instead of just using the more traditional join approach? So because it never creates the Cartesian product, there's no chance that you can have incorrect duplicate data because the where isn't specifying correctly to remove the redundant data. So that's one thing that it completely eliminates. And it might have a performance benefit or penalty depending on the data that is being run on. So yeah, that's all from my side. Thank you very much.